Okay, hello, and thanks for joining the next data science webinar. Today we have a great and informative session on identifying seasonal data with time series in Alteryx. We'll be discussing strategies for handling the seasonality dimension in time series analysis, as well as hear tips and actionable tricks from our data scientist, Dr. J. Kyle Roberts. So be sure to tune in until the end. A few notes before we get started. This session is being recorded, and the recording as well as any additional resources will be emailed to you in the next day or so. Additionally, we will be launching a few polls during this session, and we encourage any feedback or engagement on those polls to help Dr. Roberts tailor the presentation to your interests and needs, because we definitely want this to be an informative and beneficial session for you. Lastly, we also encourage you to utilize the chat or question window found at the bottom of your Zoom screen to pose any questions you may have during the session. We'd be more than happy to answer these as we kind of go along. A few introductions. My name is Rachel Mason. I'm the marketing specialist here at Technion Data Solutions, helping out with this series, and Technion is happy to be hosting this series as well as 3 other series. So be sure to check out exciting upcoming webinars such as an exclusive data strategy interview that we have with one of our longtime client and friends from Children's Hospital Association, as well as a visual analytics webinar with one of our Tableau Zen masters, who's actually in the Hall of Fame, exploring Tableau's newest data model. And lastly, a live demo and presentation on agile analytics with our strategic data pipeline partner, Fivetran. And with that, I'm going to pass it off to today's presenter, Technion data scientist and client success leader, Dr. J. Kyle Roberts.
All right. Well, thanks a lot, Rachel. So excited to have all of you here, and looking forward to a kind of a fun session looking at time series. And so I imagine that if you're in this session, you have this is one of the big struggles. It's time series tends to be that kind of weird black box that sometimes we throw data into an analysis, but not quite sure how we get the output out. So, and what was the process that went into that? And, you know, there are statistical routines kind of making decisions for us that we don't really understand the decisions and why they're made. So I think that's kind of the goal of today, is to talk about, hey, how do we set up data for time series? How can we use forecasting to predict out and then check on our models and see how they're doing? This is, and also too, I just want to bring about, this is incredibly difficult. Like this is, if I were teaching this at the doctoral level, I would most certainly spend probably an entire semester, at least, on time series. And so you're about to get a really quick crash course on this. And so my apologies up front for that. But I think that's okay. We'll get as far as we can, and then just kind of think about things in an easy way. And so hopefully you can get started with some of your data, start playing around with some forecasting, looking at how good models are, and making thoughts about that. Okay. So a little bit about myself. And so I've been with Technion for about 2.5 years. Before that, I was a professor at SMU, and then at Baylor College of Medicine. I was taught stats at SMU. Baylor College of Medicine was doing research, and then taught stats before that at University of North Texas. So also R is my wheelhouse. Like I've co-authored the Y Hat package there. And so that's some of the things I'm going to show you. There's actually even some meaningful ways you could actually pull in an R tool and do some other more difficult analysis. And so I'm not going to show those today. Maybe in a future webinar we might do that, but that's getting some pretty advanced work. But also too, my field is something called multi-level modeling. You may know that as hierarchical linear modeling. And the reason I bring that up is because I do have some favorite resources inside that I use when I'm doing time series. However, so those resources are really kind of from a multi-level framework. And I'll talk in just a little bit about what that is. And so that's going to be outside of the purview of Alteryx, but that's the area I kind of specialized in. And so, Dan, I'm going to leave this up here for just a second because I'm going to use one data set that's available on this on our website. And so, and if you go to this site, it's at the very bottom. And so, Rachel, and maybe you could post this in the chat for everyone there so that they could just click on that. So at the very bottom, there was I did a time series presentation or webinar. I guess, goodness, it's been probably 9 months ago. But there's one data set in there that the reason I'm saying that is that we're only going to use that for a very short time today, but it's a fun data set to play around with. It's all simulated data and has a really strong seasonality in it. And so when at the very end of our time today, I'm going to talk about kind of playing around and, with what you can do with different data sets. And so I have a data set up there that I think all of you will really enjoy playing with. And so I won't get to that till the very end, though. But you're welcome to look at that. Again, if you go to that webpage at the very bottom, there should be the data set there that you can use. Okay. So the first thing before we get into Alteryx, we do need to talk about time series data structure. And the reason we do is because most of you, when you have a data warehouse, this is how you're storing your data. That every time you have new data that you want to kind of append to the old data set, then you add you'll create a new variable inside that table that is, whatever that data is. Let's say it's March, or, for the next month, we would add a new variable out there for that table that is April, and we might have somebody's score there, or some score on some different thing. We typically think of this as wide data. Well, not typically. We always think of this as what we call wide data. And as you know, for those of you that are in the business of storing data, this gets very expensive in terms of process. When you start to add more, basically wider dimensions to a single table, it stores more data. Okay. As a result, when we're doing our time series analysis, we don't want to analyze our data in this wide format. We want to do what's called a long format, where we have a variable that designates a score, and then we have another variable that designates the date. Okay. And the reason this is important is because I'm going to show too that we may have actually multiple items within our data set, and I'll show you in Alteryx kind of how to fix that and how to get it so that your data is in a format that's ready to go. Okay. So that's the first thing that's pretty big. This is an easy fix for us, even though we mostly store our data wide and that we need to analyze it in the long format. Okay. The second thing is that there's multiple flavors of time series, and so there's what we call the ARIMA, which is this is like an autoregressive moving average, where it's really typically used when you're forecasting based on the most recent time points. And so you're saying basically, let's suppose you're wanting to forecast 2 weeks out. Then that 2-week forecasting period is really dependent on what happened the last week, or maybe the last 2 weeks, and dependent in forecasting in there. And so typically we use what's called an ARIMA, or even an AR model, just an autoregressive that doesn't have the moving average. We use that type of time series when we see, okay, we're really dependent on the last few observations. Okay. The ETS is the one that we're going to mostly talk about today, but we're going to kind of compare both of them. But this is typically the type of model that you use when you have a great seasonality trend among your data set. And so, and in Alteryx, you're going to note that really these are the only two that we can look at because they're the only two that we have really just the canned processes inside of Alteryx. So we have ETS and we have ARIMA, which is our two. And I should have mentioned to you, the ETS really stands for like error trend seasonality, or some people call it exponential smoothing, but it's like an error trend, and the S is seasonality. So we're kind of, we define our season, or what we kind of, sometimes we'll let the computer define the season for us, or the algorithm define the season for us, and then move on from there. Now, the one that I think is actually, it's not available in Alteryx, but it's the most powerful one, is one called multi-level time series. And so this is used when you want to incorporate something called random effects, and you also want to model what are called time varying covariates, meaning that you have variables that change across time. Now, typically, most of the time when we're doing ARIMA or ETS, we're putting in variables in there that don't change across time, meaning like we may have ethnicity in there, or or for, if we're modeling people, or a model that, it's coming from different stores, our scores are coming from different stores. So there's a covariate in there to look at our time series. But anyway, when we have both time varying and non-time varying covariates, we want to move into this multi-level time series area. Now, again, I'm not going to talk about that today, because that is a lot of either using R code or buying really specialized software, something like a software called MLWin or even HLM or one of those software packages. And so I want to talk specifically today about Alteryx. So multi-level time series, really, really interesting, fascinating to me. But this isn't something we can do inside of Alteryx without actually using our R tool. Okay. Now,
real quick, Kyle, do we want to launch a poll real quick?
Yeah, absolutely.
We were just curious, what is your primary application of time series data? So we'll allow just a few seconds for you guys to answer the poll. Okay, let me share the results here.
Forecasting. Okay, that was probably my thought, that most of you would be doing forecasting type models. So that's interesting. The few doing an optimization and anomaly detection, and a couple doing something other with that. Okay, yeah. So most of what we're going to show today is forecasting. Now, Alteryx does have a new tool on optimization. I think it might be worthwhile for us to do a session on that later. Won't have time for that today, but and also too, that's kind of a different animal. But it is a period of time series, and then anomaly detection being the same thing. There's a different way we would do that inside of Alteryx. Okay, great, Paul. Thank you for the feedback on that. So, all right. So these are my favorite time series resources. So now the one on the right, data analysis using regression and multi-level hierarchical models. That's not really time series per se, but they do address it in there. I love Gelman and Hill. In truth, I love statisticians who are humble and nice, and so who are really brilliant. Andrew and Jennifer, they fit the bill on that. And so now that one is done almost exclusively in R. And so that's if you are looking for a good regression handbook. But then also they cover time series in there and multi-level time series. I like that book a lot. Really user-friendly. Really does a great job of taking complicated concepts and making them simple. My favorite longitudinal data set or time series time series book is this Applied Longitudinal Data Analysis by Singer and Willett. I don't know John, I do know Judy. She is wonderful. So there's actually even also too, if you just Google this, there are some websites that even show how to do everything that they have done in multiple packages. So whether it be in R or in SAS or in other those specialized packages like HLM, that really, really good, really impressed with this book, easy to read. My students used to love it because it's really complicated, but it's written in a way that pretty much anyone can understand it. So love that data set. They use, now I will say this, most of their references are in either educational or psychological research. Anyway, really, really great book. Okay. I think that's all for right now. And so I tell you what, let's do, let me get out of this and then we will, let me give a new share and I'll pull up and we'll fire up Alteryx and we will we'll kind of talk through how we do some things. All right. Okay. All right. So if you want to follow along with Alteryx, I'll give you just a second to do this, but let's first talk about this wide versus long format. And so I've just used my text input tool and I've created a data set that is a lot of the times this is what it would look like when we get data and we're pulling it out of our data warehouse. Okay, a lot of times see data that looks like this. So if you can see down here, I have items 1 and 2, and then there's a date time stamp or just a date stamp there. that is, okay, there's that first day of January 1st of 2020, the second day, third day, fourth day. And then we have scores for each of our items, okay? Now, Alteryx makes this pretty easy to do in order to transform this. And I'm going to go up into these, this transform tab in Alteryx, and I'm going to use the transpose tool, okay? And pull that down into my data set. And when I do this, you'll see that the tool inside of Alteryx actually gives me what are called key columns and data columns. Now, my data columns exist in these date fields. The key column, this item, the reason we're doing that is think of this like a grouping term. And so again, if we're going back to here, I don't want to concatenate all 8 of these scores in a single column. Without honoring the fact that these first 4 scores came from item number 1 and the second that came from item number 2, or second 4 scores came from item 2. So now that I've pulled in this transpose tool, I want to make sure I've, the key column, think of that as your grouping column again, and then all of my data exists in those other fields. So let's go ahead and run this, and then we'll look at our results. Okay, all right, so I've got a variable called item, that was our grouping field. I've got these dates, and Alteryx calls it name, and then I've got those values there, 1, 2, 3, 4, and 7, 9, 8, 15, which is those do correspond there. Now, what I do typically is I pull in a select tool after this because I want I want things named what I want them named. So, like for example, here I would call this one date. And I would change that to a date format. And I don't like the value that being called value, and so I might change that to score. And now we can see, all right, now we've got good. And now if I wanted to, I could just take the scores for item 1 and then run my time series with those, or I could run this and use, item as some sort of covariate in there. But that is how we take that. It's literally that simple for taking that wide data that's coming in and then putting it into a long format so that now I can use it in my analysis. Okay, so that's the quick of it. Our data has to look like this in order for us to be able to use it in our time series. And so now we're ready to go if we wanted to. We're not going to run a time series on something that just has 4 data points though, or 4 different times, okay? All right, so let's actually create a data set that we can run. Okay, so what I'm going to do is I simulated a data set inside of R, inside of Alteryx, and so just using some stuff. And so what I'm going to do is I'm going to paste this code into the chat. Let me pull up the chat real quick. Okay, and let me make sure this is going to everyone. There we go. Okay, so now all you would need to do is copy this code out of the chat. All right, so you would just copy this, and then you want to open up an R tool. And you can get that, that's multiple places in Alteryx. So you can either get that in the developer tab, or if you go up here to the search, you can just type R and then drag it down in there, okay? And then once you've got that, if you click on your R tool, then you copy and paste that stuff that's in the chat into here. And really all this is doing is, I can talk you through this real quick. The set.seed is making sure it's kind of like an initializer for the random number generator. And what that is doing, that first part, is making sure that we are all going to get exactly the same results. Otherwise, it'll kind of be random. The second part is creating a variable called time series that's using this arima.sim, and that's simulating the ARIMA data on this order. For those of you that are familiar with ARIMA or time series, that's my PDQ, and so I'm setting that up. And then also too, there's some other things in there. So I'm actually adding, I'm doing this for 50, and I'm saying that 20 is kind of that starting value to base that on. Then I'm putting that into a data frame called TS, where I've got an ID variable in that time series that data that we created. And then I'm writing that out into the first node here. And so now if we look at that, here are our scores. There's all 50 of them. Okay, all 50 of those scores. And I purposely create them so there's a little bit of seasonality in there. But then I added this filter, because what we're going to do is we're going to work with the first 40 scores, and then the other 10 that are coming out here, we're going to use those later on to kind of see how well did our model do. Now, you can use the create samples tool. So if we're back in, if you wanted to use the create samples tool like this, the thing I don't like about that is that the create samples tool, for our purposes, it wants to create 3 samples for us, and we really only want 2. We want to forecast the last 10, and also it grabs a random percent, and we don't want percentages. Ours are in a linear format, meaning that they've got that date time stamp in there, and so we don't want to use this create samples tool when we're wanting to look at time series. Okay, so I'm going to stop for just a moment and just make sure everybody's caught up, and then make sure there's no questions that are coming through yet. I think Rachel, we're good on questions, it looks like.
Good so far.
Okay. That also gives me a chance just to get a drink. So, okay. All right, so what's the first thing we're going to do when we have the time series is, again, we're just going to work with these top 40. And so all of our time series stuff is connected over here. If you see this pink tab, right, there's time series. All right. And so the first thing I always like to do is pull in this TS plot. I want to look at what my data look like. So I'm going to pull that in. All right. And I've got to tell the Alteryx a few things about my data. Okay. The first is I want to this target field frequency. If we look at that coming out, we can see we're just going to, there's no date stamp there, but we're going to call this daily data. Okay. We're just going to assume that it's daily. So I'm going to put daily, and then the target field that I want is going to be score. Okay. And I'm going to add all my browses. Okay, so now the one thing here is that some of you will note that you can't, when you clicked on your or when you pulled in the filter tool, you may not be able to populate or see those values like ID and score. You have to run the R stuff first in order for that metadata to push forward. Okay, but again, in my TS plot or time series plot, I'm selecting the target field score daily. You can leave on this plot type, you can just leave it as time series. We're actually going to get all of those. So we're going to just run this, and then we'll talk about what comes out after. Okay, Rachel, did we have a question? Was there?
We do. If you want to answer this now, it says, it's a question from Carter. When it comes to seasonality forecasting in a healthcare space that's experienced COVID-driven demand fluctuations, how would you handle this past year's worth of data?
Yeah, I might roll it up in a ball and set fire to it. That's a really, really great question. And we have been asked that so much over the last 6 months. Is what do you do with COVID? Man, if you have a good answer to that, that's the $20 billion answer, right? No, this is a one-off. We haven't seen something like this ever in the history of the United States or most other countries either. I mean, that's, if you had data that was related to the Spanish flu or something like that, that was affecting all of these. I mean, we just didn't collect really good data in a pandemic like that before. So I would not, so that's a great question in how this relates to what we're doing right now. Remember that I said before, I would not, that ETS is really looking at seasonality trends, and then ARIMA is looking at that's what we call an autoregressive moving average, meaning that you're weighting the last few observations a lot more than you are weighting seasonality. Okay. In that sense, I would immediately after COVID happens and we recognize what's going on, I would not trust any of my seasonal predictions unless I thought I was immune to that. Okay. So meaning that I'm looking at it and going, all right, in healthcare, you still have some seasonality issues there, but it's gosh, I mean, that's, staffing is going to be all different. I can't think of much that's going to say the same, especially with some of our healthcare clients that they've called and go, hey, what do we do? And we're like, we're as lost as you are. It feels like right now we're throwing a dart against the wall and then drawing a target around it. So I wish I had really good ideas on this. The only ideas that I say is I wouldn't use an ETS model. I would use an ARIMA model, and I would set up that model to be weighted very heavily on what happened yesterday. So when you're predicting 14 days out, let's say for hospital staffing, and all of a sudden you've just entered into that, COVID structure, I don't know. You're going to get better the more data you get. But when you're trying to predict that even a month out, man, that's a hard space. That's a hard space to be in. Now, having said that, also, let me add one more thing on this. In a COVID world, you want to run competing models every day, meaning that you never want to go, all right, here's our model, we're going to trust it, we're going to run with it. Every day you're running competing models, because it could be that you're running a model that you say, hey, we're going to lean heavily on the last month of data. And then now you need to lean heavily on the last 2 days worth of data. And then as COVID starts to slack out, you would say, okay, let's lean on the last 14 days because we're seeing some more stability in the trends here. But every morning, if I were your data scientist, I would wake up and I go, let's rerun every model we have just to see where we are. Okay. I'm sorry, that was a pretty long answer to a really short question, but COVID has been nuts. I don't trust any model before then. So just don't trust any of them. Great question. Okay, so let's look at our output. So I'm going to click on this bottom node because I actually get more information here than I do the top one. So, and then once I've clicked on that, if over here in my viewer window, there's this little square with a plus in it. If I click on that and do the new window, all records, and I get a pretty good way we can see this. Okay. Really, really good. So here's our time series plot. And that if we're looking at, again, if I scroll over any data point, this tells me it's looking at days. And so what it did is, because I didn't have a date stamp in there, it's just looking at this. So if I hover over it, you see up at the top right there, it's saying, all right, there's February 3rd, 4th, 5th, 6th, and it gives me those actual values. And so we may be, from the last 40 days, it may be that we're seeing a little bit of a seasonality here. Okay. That's a really good idea. A really good seasonality. I think that we're probably seeing there's one dip up and then there's a dip there. And so we expect that maybe it's going to go up again and then another dip. Okay. Here again is a plot of our data. Here is this looking at, are we seeing a seasonality component? And so again, if we're seeing what's called a trend over and over and over again, that's a good idea on that. This is the trend. Is it down? Is it up? So this one is like a smoothing, if you will, of the actual data. And then this is what we call a remainder or residual decomposition plot. Okay. Now here is the other part that I like looking at. Okay, so this is the autocorrelation function plot and then the partial autocorrelation function plot. So if you remember before, when we said that in the ARIMA, you're looking for these parameters called PD and Q. That's what you're looking for. Those are determined based off these plots. And so what you're looking for in this is the point at which these autocorrelation functions, these lags drop below these dotted lines. And so in essence, after the fifth one, there's a drop, and then on the partial autocorrelation, it looks like after the second one and into the third, that drops below that. And so the reason I talk about that is that what we're looking for is something called stationality or stationarity. So we're looking to see if when we start to see some stability in our data. Okay, and so these autocorrelation functions are basically saying, how related is each period forward to the periods previous? And so when you see that there's a lot of dependency going forward, then you're saying, all right, in order to model this correctly, I'm going to have to go back in what we call lags back to a certain point. And so in this case, we would say, all right, we're going to go at least 5 lags back, and then on another, so on that p value, and then on that q value, we're going to actually go at least 2 back. And so those are, and the reason this is important is because when we run these models, you're going to see that Alteryx is going to automatically pick those values for you, but it's based on how it's interpreting these 2 graphs right here. Okay, and so a lot of dependency going pretty far back. And then if we think of this and being also some dependency too, of the in that case, we're really kind of looking at, all right, where is that value that we would say, all right, this is how much we're going to depend on what was coming from us previously. Now, Alteryx also too has these little eyes here, so that's not helpful. It's giving us the same. So I just did want to point that out also, is that even though there's that eye there, you're not actually going to get any more information from those. Okay. All right. So we've looked at our data. We see there seems to be some seasonality in there. And we want to look even further into this. And all right, now how are we going to model this? So what we first want to do is we're going to run an ARIMA model, and then we're going to look at, all right, how did that function determine season? And then we're going to run a seasonal model in ETS. Okay, so the first thing I want to do is I'm going to kill this plot for right now, just because I want it to run fast. So first thing I want to do is ARIMA. This is what we would think of as, if we did notice seasonality, this would be kind of the wrong one to run. So for this one, I'm going to call it ARIMA 1. And then the target field is that score. Okay. And I'm going to look at daily and all days. And then, so now on all the model customization, we were talking about before that if you did want to change those PDQ components, this is where we would change that. Okay. But what we're going to do is we're just going to let Alteryx pick forest. So we would probably change that to 5 and 2 if we wanted to, those P and Q components, right? At the degree of differencing would probably be 1 in this, but again, that's another question for another day. Okay, so we're just going to let Alteryx pick all our options for us. We've given it the score. That's the variable that we want to use. We want to go with daily, and then we're going to add all of our browses after, and then we're going to run this. This will just take just a second. Okay. And again, I generally like these nodes here. The top node, that's where the model comes out. So we'll use that, further down. Think of this one as being like further downstream if we want to do stuff to the output. This one, the middle node, this is the report from R, and actually is giving you the code that it would it using the auto ARIMA. Right, so there's the code that it would use in order to do this. That's the function inside of R, and it picked for us what we call a 212. That's those PDQ parameters. A 212 model for us. Okay, and it says, all right, based on what we saw from previous, that's the type of ARIMA model we want to run. And then let's look at our output just to see kind of how we're doing here. And I like this because I can think of this in terms of forecasting. So, okay. So in this, we've forecasted out, let's see, it looks like, I think 7. 1, 2, 3. No, I'm sorry, just 5 points out, I guess. Okay. All right. So what is happening here is that Alteryx is saying, all right, in here, as we're going out in time, here's what we're predicting these next few points to be. Okay, so remember we had 40 points, so that's that 40th point on February 16th, because or I'm sorry, February 7th, 16th, sorry, because when we add January and February together, those would be kind of those 40 days out that we're using in order to do to actually fit this. Okay, and so as we're going out from there, those are those new predictions that Alteryx is predicting for us, or actually the auto ARIMA function inside of R is predicting for us. Now, so here's the problem. As we're looking at this, it looks like we really want these autocorrelation functions to stay within our bounds here, 0.2 and negative 0.2, positive 0.2 and negative 0.2. And the same thing with these partial autocorrelation functions. And so what's saying is that, man, when we go 10 points back, or think of these lags as being how far back we go, we really miss the mark when we think about in terms of predicted versus actual, okay? So let's think of it this way. All right, we're starting on January 8th, and we're predicting for, let's go 10 days forward. 4, 5, 6, 7. There's January 18th. Okay, you see how we've had a pretty serious dip there, okay? And that we're trending down, but then if we go another 10 days, the 28th, we're starting to see another. And so what this is telling us is as we get to that 10th point, we tend to see a pretty huge difference in what we were watching previously, or the type of predictions we were making previously. And so another way of thinking about this is saying that, hey, there's something going on inside our data set that we're doing, for these first few lags forward, we're doing pretty good. But when we get to that 10th one, that's when the things really start to drop off. And so another way to think about this is that if you're predicting much more than 10 points out, given this data set, you're probably having some issues. Okay, probably going to see some problems there. Okay, so in looking at it, this would be the first thing I'd want to look at, is just to look at, okay, how are these functions looking based on time? And do I really recognize this as some sort of seasonality? Like, okay, here's a down and up, and then is this a down, and is it going to be another huge up? Okay. And have we gone up far enough? So how are we going to recognize that next level of seasonality in there? So in this case, I would definitely want to, as I'm looking at this, I would want to pull in now my ETS tool, because I know, boy, this one is going to get the seasonality component. And so we're going to pull in that tool. We connect it up. And just like with the ARIMA, I'll call this ETS1. We're going to select the target field as our score. We're also going to call that as daily. All right. And again, on these model types, we're just going to let Alteryx right now pick everything for us. On the error type, all of these, again, probably beyond the scope of what we want to talk about today. So I'm going to let Alteryx pick all of them for us. And then the other options. Okay. All of these, let's just leave them alone. We'll add all of our browses. And then I'm going to hit run, and this will take a second to run. And so then what we'll do is we'll look at the results from the ETS, and then we want to compare these two different models to say, all right, are we really having, is the problem that our data is really sparse, or we're having trouble picking up the signal from our data, or is one of these really functioning better than the other? Okay. All right. So now let's grab the ETS. And in this case, all right, looks like, do you remember how the ARIMA one, it looked like it was starting to curve back down, but what the ETS is saying, no, I think we're still trending upwards here. Okay, I think we're still trending upwards. Okay. And so from the forecast going forward, okay. And then we're hopefully starting to see some sort of, the trend is actually being honored a lot more here as going up, whereas with the ARIMA, it was starting to kind of curve back down again. We might also want to look at some of the other outputs. from R. Okay, so there are also the plots. And I like this in the ETS also because this is actually giving us a little bit better understanding of what we would see, of what's going on with our data. And so if you can see here, this is our actual observed. This level, this is what we would call kind of a baseline prediction without seasonality in it. And then where's the season? Okay, there we go. So this next one, the slope is showing what we call the rate of change at each point. And so you see that this is the slow rates of change or trendings are going to be downward versus the rate of change is hugely up. And so you see it starts to flatten out in this general area. Okay. And so what we're trying to see is get an idea of are we seeing actually a seasonal trend? And it looks like we are starting to pick that up a little bit. Okay. And then here's more information that you would want to know basically about your model. Okay. So let's do this. Remember, we held out 10 people in our model, and let's use the ARIMA model and then the ETS model. Okay. And let's see how good each of them is at predicting those other 10 data points. Okay. So the first thing I'm going to do is pull in a union tool because I need to put these two models together. So I'm going to grab the output from the ARIMA and then the output from the ETS. And remember, we named them. We named this one, if you remember, we named it ARIMA 1, and this one we named ETS 1. Okay. So we'll union those. And then in our time series, there is a TS compare, okay, that's going to let us compare the two different models. So I'm going to grab that one. There's TS compare, and I'm going to have it come into the left side. And then these last 10 data points, I'm going to have come in from the right side. Okay. All right. And then
we have one quick question.
Sure.
From Colin, when Alteryx is comparing models when selecting optimal parameters, is it using a validation set or all of the data inputted? Would there be a concern of overfitting?
Yeah, so it's not using a validation set. It's actually using all of the data that we have when it's running the model. So that's a great question. It's hard to overfit necessarily in ARIMA and ETS, but there is that aspect of because in the good question in there for Colin is that if typically overfitting becomes a problem when you start to do forecasting because you don't you're so specifically defining what your error terms are. This is a personal thought on this. I tend to think that we don't have as much trouble in ARIMA and ETS and overfitting as we do in something called like a structural equation modeling, where we're really monitoring very complex structures of our error, and we do overfit there. For the most part, I don't think that's going to be an issue. I'd say 99 out of 100 models that you're doing here, if you just go with the defaults, you're going to be okay. And so good question, though it's not, but this is where we can also, this is why we do our own holdout here, is because of the question that Colin said, is that if we just absolutely are 100% missing going on the forecasting forward, then we probably are overfitting our model, or we're just not getting enough signal from the model in order to be able to detect it. But that's a great question. Great question. Okay, I'm going to hit run while it looks like maybe we have another question. So this will take just a second to run, but Rachel, do we have others?
I think we're good. Colin says thanks.
Okay, absolutely. Yeah, good question though, Colin. All right, so this is, now we're running, like I said, we're running our ETS, ARIMA and ETS. We're going to use the next 10 data points. That's why we did our own holdout to predict forward. All right, and so this, actually I want to see, not that one, this one. There we go. So I typically, the MAPE is the one that I usually care about on these models. And so what this is doing is it's comparing what's called the MAPE for the ARIMA and the ETS. MAPE, the way to think about that is that's saying, let's suppose that I have a terrible fitting model, meaning that let's say I used as a fit just the mean of all the data. Okay. This is kind of a measure for how much better, that's the good way to think about it, is if I just guess the mean every time going forward, how much better is my model doing than a terrible model? So lower values for this are better. So when I'm comparing these two models, if I'm looking at that MAPE and that's a lower value, what that is telling me, and this is kind of how we identify that seasonality, is that the type of model that has seasonality built in versus the one that does not tends to produce smaller errors. And you can also see that here with that root mean square error. Tends to produce smaller errors than does the ARIMA one. And so the one without the seasonality. So this is a really good way of looking at that. There are also some graphical ways we can look at this. Okay, so this is, if you're looking at this green value here, that is the actual data, okay, the actual data. And then it looks like the purple, it's kind of hard to see on my screen, but it's probably better on yours. The purple one is the ARIMA, and then this turquoise-ish color is our ETS. And so as you can see, what really we're computing is what is the distance, or like it's almost like an average distance at each time point from this green line and the turquoise line and the green line and the purple line. Okay. And so what it's doing is it's saying the ETS one is doing a bit better. So because it looks like the ARIMA model is kind of flattening out, whereas the ETS one is starting to see a bit more of an upward trend. Okay. Now, again, I would also look at this and go, not awesome, probably need more data to train on this. And so, or I'm not quite picking up the seasonality at the right time. Now, it could be though, that if I were predicting forward 10 days from this point right here, or when it starts to turn up, that I'm doing really good at predicting during this period. But then when we have this kind of dip down and back up, that's when I'm struggling. So it does make sense that at certain times of the year, especially with the seasonal model, that certain times of the year that you're good at predicting, better at predicting certain things than if you are during other times. So for example, if I'm trying to predict, let's say if I have a data for predicted sales for a weekend, then it stands to reason that by Friday or by Thursday, after I have my data in for Thursday, I'm probably a lot better at predicting Friday and Saturday than I am at predicting Friday and Saturday a week before then. Okay. So typically the closer you are to the data point you're trying to predict, the better you will do. Okay. So now that's why also too, it sometimes makes sense to build different models based on what you're trying, or how far out you're trying to predict, or how much, how far out you're going. I might run if I'm doing daily data, I might have a different model for predicting Saturday and Sunday than I do for predicting Monday through Friday. Okay. That just may make sense. And in fact, there's a company called TangentWorks that actually has made they took that principle and to the extreme, where they are in their time series forecasting. They say, okay, the model that we use to predict 1 day out is a different model than we would use to predict 2 days or 3 days or 4 days or 5 days. And so they've actually taken that thought to the extreme. Now that's a lot of processing power to be able to do that. And so again, that's something you would want to run on Alteryx server, not on your desktop. Okay, great question. Okay, all right, great thought. Now, the last thing I do want to show is that, so we've decided, let's say we've decided that we like the ETS model and we want to predict out forward. We want to predict, let's say, the next 10 days. How would we do that? Let's say we didn't know what the next 10 days were. In this case, that's where we take this TS forecast, we pull that down, grab our model, have it run into here. And then again, if you're using something like Promote and Alteryx, this is, we would use this forecasting tool and Promote. And then this is where you get to say, all right, let's predict 7 days into the future. And so I might call this ETS forecast. And then now what's really nice is we get all those browsers after. And when we run this, it's really great because what we will see is that score then forecasted with confidence intervals around our data. And so let's take just a second to run. Okay. And as we're running, I think Rachel, as soon as this result is up and I show this, I'll be done for the day and I'll turn it back over to you. Okay. So that was the plot before, but actually, sorry, that's not what I want. Here's what I want. So that's looking at the next, basically the next 7 days. Okay. And there's the forecast with a 95% upper and lower. There's the upper, there's the lower, and then the 80% upper and lower. Okay. Which is helpful. So it can help you make decisions about what to do later on. Okay. But that's kind of how you identify seasonality, is generally with the tools that we have available here. You want to run the ARIMA, you want to run the ETS, then compare them against each other, make sure that you're able to pick up that seasonality trend that you see. Well, we didn't have time to get to the data set that I had before, but suffice it to say, there's some really great season. I mean, it's ridiculous seasonal data inside that one that I created before, but you're welcome to play with that later on. Okay, I'm going to stop. Rachel, I'm turning it back over to you.
Great. Thank you, Kyle. At this time, we'll allow you to pose any questions you may have in the chat or Q&A. I see one already asking for the data files again. So let me share that real quick in the chat, and then we'll be sure to include this link in the follow-up email as well as the recording. As you can see on Kyle's screen here, that you can check out our whole webinar series on our homepage of our website. So we have the data science series. We also have data pipeline, visual analytics, and data strategy. And we have quite a few webinars coming up soon. So be sure to check out all the exciting sessions we have in store. A quick poll that I want to launch real quick while we're waiting for more questions, if there are any. Is how can Technion potentially help you with your time series analytics? I know Kyle has worked on several different projects in these areas. So if you are interested in either reaching out to Kyle about these topics or just have interest in these, we wanted to pose this as well. Oh yes, and then Kyle reshared the R code in the chat as well. But like I mentioned, we will include the recording and then any additional files in an email within the next day or so. Kyle, one question we have is, can you show settings on the last tool used? I think it was the TS forecast.
Oh, absolutely. Yep. Let me pull that back up. Okay, sorry, I had to get rid of some of these things on the, there we go. Settings on TS forecast is, again, we just do 95 and 80% on that. I grab it from the output data node or from the model, and then I just went 7 periods into the future. Okay. Rachel, I think I did see a question though that was about do we do RPA or robotics process automation? Was that, is that right? Did I see that? Okay.
Yes, does Technion work with RPA?
Yes. So yes and no. So we do a lot with, especially with I think Alteryx is a good tool for doing RPA. And so we do a lot with Alteryx. We can build a custom solution inside of R or Python if you needed something to do RPA, like make decisions for you and then automatically, ping some other source. We prefer to do it in Alteryx because it is easier to automate that process and actually set it up with scheduler through Alteryx server. Now, if you're looking for something though, and here's why I said no. If you're looking for something that does RPA like something like UiPath, that UiPath does RPA by like actually clicking through things on a website or something like that, uploading a file, setting the parameters, and when you have certain clickable things, if you will, that are needed to do for, let's suppose you're in banking or financial services and you're working with like a Syntrax file or something like that, where you have to go into the Fed's website or your own website and click through certain things. You need a tool like UiPath to do that. It's probably the best tool out there. And now, again, we can help with setting that up. But when you're talking about RPA, meaning like you want a system that does a certain set of criteria and says, all right, let me know when we need to do ordering and then actually place those orders for me or something like that. Absolutely, we can certainly help with something like that. And actually, this may be one of the better tools to use to do that, because you can also kick off R and Python inside of here. And so if you have an automated ordering system or something like that, then we can, all those orders can be generated inside of Alteryx. It's a great tool for doing that, but great question. And also reach out to myself or Rachel or Dave Haas is also on the call here. We can help you with that, or we can also tell you, we can help you with that, or no, that's outside of our expertise. So great question. Any others?
I'm not seeing any yet, but like Kyle said, feel free to reach out to us. And then those that answered in the poll, I'll be sure to forward those to Kyle so that he can reach out to you as well. And if we don't have any other questions, I just want to say thank you, Kyle, for another great session. And that follow-up email will come out in the next day or so. So thank you so much for tuning in today.